Okay, so this will be our introduction to tuples in Haskell. So tuples are kind of similar to lists in the case that let's think of a list. We actually have an element followed by a comma and then another element and so on, however many we may want. And one of the big differences between tuples is that let's imagine we had a list and one of these elements were of type int, right? Then all of these elements would also have to become type int, right? Because the type of our list is basically a list of integers, right? This is because this is because lists in Haskell are not heterogeneous, which tuples actually are, meaning that, so if I were to write a tuple here, so let's just show you that to write a tuple, you basically do the parentheses, and then exactly the same, you have an element, and then you have the element separated by comma, element and separated by comma, and so on. You can have however many elements in a tuple that you may want. You can have 2, you can have 3, but one big difference is that let's say that this element was an int, so maybe a 5, okay? And let's say that the other one would be a string, okay? So maybe this would be a name, so let's say John. And maybe the third one, or maybe the first one can be age. So let's say that he's 24, John. And maybe the third one can be where he lives, or maybe what his first character of his last name is. So let's say that it's John Johnson, so it's J. Okay, it's his name Johnson as his last name. But one thing, basically, the type in this case, type of this tuple, let's just write up here as well. The type here is basically just list of ints, but the type of this tuple would basically be a tuple, okay? A tuple of size 3, okay? Which is int followed by string followed by car in this situation, okay? And this is very important to understand, because let's say that we had two tuples here. We had one that was just 2 integers, so 1 and 2, and then we had another that was maybe a 1 followed by a character, so let's say character C. These two tuples, they can basically not be they cannot be compared to one another, because remember the type here. Okay, so basically the type is determined, you can write determined by, and it's size, order, and also the types of these. Okay, so let's think here. The size, they're equal, right? Both are of size 2. The order, this is not correct, right? Let's say that let's instead say that this was also a character here, but it was this, right? So size and types, that's correct, but the order is that's off, right? Because here we have a character followed by an integer, and an integer followed by a character. So these two tuples, they would not be able to be compared in this case, and that can be useful to know. But okay, let's get into the example here. So let's say that we wanted to represent fractions with tuples. So let's say that we had a fraction like 2/3. Okay, we could basically make this into a tuple by just doing this and replacing the divide sign by a comma, right? Or the slash by a comma. And this would basically be an implementation to fractions in Haskell. So let's say that we wanted to make 2 functions. Let's say that we wanted to make one function that was add fractions, or add fraction, and then also multiply fraction. Okay. And let's say that our signature then would be that we take in 2. So we would basically take in 2 tuples, right? One, basically one fraction, and then take in another fraction. And here we can just say that we're gonna have integers. Make this a simple example. And then we would also return. We would return the basically the results of these two added together. And if we were to write this, I can actually do this. So I type add fraction. Oh, fraction. And we can give our tuples some variables. So let's say a and b. This can be whatever you want. Yeah, it's basically whatever you want it to be. And the way that we would return this last tuple is by basically having tuple signs, and then we can basically do the calculations inside of this tuple. So we will basically have something here and then followed by something. So let's start with the denominator. Okay. So what is a way that we can basically make sure that the denominators in this or in these two fractions are the same? We can basically just take the denominators and multiply them together, right? This would always give us a equal denominator in both of our terms. But let's think about this. We basically multiplied b by d, so here we would also have to multiply a by d, and then we would add our other. So and vice versa, since we multiplied d by b, we would also have to multiply c by b. Now I won't be writing a function to simplify these or anything. We will just have this as is. This is just a simple example. Let's say that we did add fraction, and let's say that we had 2 tuples. Let's say a half. Let's maybe make it simple and type basically 1/2 and a half. So this would return 1, but of course it wouldn't return 1 in our what should I say, or in the simplest term, it would actually return 4/4, which is 1, and that's fine in our example. But let's say for our fraction, it would have the same signature, because we're still working with integer or basically tuples of 2 pairs of integers. But here I can actually show you a built-in function that we can use on tuples. So let's say that we had instead, let's just say a and b. Okay, so in this case, our a would then be equal to, let's say that this, or let's actually name them x and y in this case. And then our x here would basically be equal to a and b, right? And our y would basically be equal to C and D. So now what we can do, if we wanted to multiply these together, we could make the same thing, that we make a tuple here, and it's going to be a comma by just separating the two things. So let's think here. When we multiply a fraction together, what do? We just multiply both sides, right? That's simple enough. But I don't have the elements, but there are 2 built-in functions, first and second, okay? And this will basically take the first element of a tuple and the second element of tuple. And this is useful in this case, because we can basically do that our second of x times second of y in our denominator, and our other one is going to be first of x times first of y. And this is basically going to be the same thing as writing this. Maybe you think it looks more neat, maybe you don't. It's just good to know that you have these functions. They are quite useful. They are quite useful in some cases where you just want to take the first thing. Maybe that's going to be the name of someone, and you basically want to compare that to match with our result. So let's say that we wanted to do this, and let's take 1/2 and then take 2/3. And as you can see, this would then return 2 divided by 6, which is calculation. Yeah, so that is just a simple introduction to tuples. Of course, I will be going further in depth or more in depth in future videos. I'm just trying to cover all the bases here on a very light level, and then we will be moving on to more complex and more advanced code.